Alright, problem number 2. Now the first part of this problem is just defining what the factorial of a number is. Okay, so if we have any number n, then the factorial of the number is the product of all of the positive integers less than or equal to n. So I give an example here of 5 factorial would be equal to 5 times 4 times 3 times 2 times 1, right? And so, but the actual question asks, how many positive cubes divide 4 factorial times 5 factorial times 7 factorial? So, first of all, the positive cubes. What's a positive cube? Well, the cube of a number is just, like 2 cubed equals 8, right? Or 3 cubed is equal to 27, right? So we want to know how many numbers that are cubed, like 8 or 27 or any other cubes, 5 cubed or 15 cubed, who knows what all divides this. So let's try and figure that out. So how many cubes will divide into this number? Now this is going to be a big number, so I wouldn't recommend actually calculating that all out. But let's write it. Let's write it out explicitly. Get rid of the factorial signs and just work with the multiplication. Okay, so 4 factorial is going to be 4 times 3 times 2 times 1. 5 factorial is going to be 5 times 4 times 3 times 2 times 1. And 7 factorial is going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. Alright? So I want to figure out how many cubes will go into this number. And probably the best thing to do here is just to break it down even further than this. Break it down into its prime factors. Alright? So, 4 is 2 times 2, right? 3 is prime, 2 is prime, 5 is prime. Here's another 2 times 2. And we have 3, 2, 1. 7 is prime. 6 is 3 times 2. We have 5. We have another 4, which is 2 times 2. And then the rest are prime. We really don't have to worry about the ones. Ones aren't prime, but we don't have to worry about those, okay? Because one is a cube. It is a cube. But let's just look at the prime factors of this number. Alright, so let's start with the lowest prime number and figure out how many 2's are in this, how many factors of 2 there are in this whole number. Alright, this whole thing. Alright, so we're dealing with this. So how many 2's we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 2 to the 10th, right? How many 3's do we have? 1, 2, and then we have a 3 in the 6 and another 3, so that's 4. So we have 3 to the 4th, right? And then let's look at the next prime number would be 5. How many 5's do we have? We have 5 here and a 5 there, so we have 5 squared. And then the next prime number would be 7, and we have 1 7. So that's just 7 to the 1. Alright. So this is the prime factorization of the number. And if a number is a cube, then it has a prime. All the prime factors in that number are cubes. Okay. So, for example, one prime factor of this would be like 2 cubed, because obviously, 2 cubed will go into 2 to the 10th. All right. So let's look at the possibilities for the exponents on the prime factors. All right. If the factors that are would be cubic. Okay. So let's look at the factors involving the base of 2, alright? So you could have 2 to the 0, alright, 2 to the 0 is just 1, and that's a cube, and that would divide it, right? So the next one would be 2 cubed, alright? Obviously 2 squared and 2 to the first, you know, they're not cubes, so the next cube would be 2 cubed. I'm going to give myself some more room here. Alright, and this is just kind of heading here. And then 2 to what? The 6th? So that's essentially 4 cubed, right? And 2 to the 9th. Alright, so that's basically 8 cubed, right? Because 2 to the 3rd to the 3rd. Alright, so these are the possible exponents on the power of 2 that will be cubic factors of this number here, right? We can't go to the next cube, can't go 2 to the 12th because we only have 10 2's, and so 2 to the 12th isn't going to divide evenly into this 4 factorial times 5 factorial times 7 factorial. Alright, so now let's look at the factors of 3 that would give us cubes. Alright, so 3 to the 0 is again 1, and 3 cubed will divide into this, and anything higher will, anything higher than 3 cubed isn't going to work because we only have 4 cubes, or 4 3's in the number, right? So the power of 2 that would give us a cube would be 0, 3, 6, or 9, and the power on 3 that would give us a cube is 0 and 3. So we can just look at all of the permutations of those, okay? So essentially we can choose the power of 2 and then choose the power of 3. And then again we have 3 to the 0 and 3 to the 3. So we could choose, if we choose 2 to the 0, then we can choose either 3 to the 0 or 3 to the 3. So that would be either 1 or 27. And if we choose 2 cubed, we can either choose 3 to the 0 power or 3 cubed. Alright, so that would be either 8 or it would be 8 times 27, whatever that is. I'm not going to take the time to calculate it out because really all I want to know is how many of these. I don't actually have to know what the cubic factors are. If I choose 2 to the 6th, I can again choose either 3 to the 0 or 3 to the 3, and that would give me what? Well, I think this is what, 64, and then this would be what, 64 times 27. And if we choose 2 to the 9th, then we can either choose 3 to the 0 or 3 cubed. So that's either going to be what? So 3 to the 0 is 1. So this is I think it's 512, and this would be 512. 512 times 27. Okay, you know that's going to be a cube because the factors are cubes, right? 512 is a cube and 27 is a cube. So, and how many do we have? We've got 4 choices for the power of 2 and 2 choices for the power on 3. So we end up with 8 factors, 8 cubic factors that will divide into this 4 factorial times 5 factorial times 7 factorial. Okay? You just count them up, and here they are. If you wanted to know what the actual factors are, you could calculate all these out, and they would be 8 distinct factors of this number that are cubes. So there you go.